Hello and greetings to everyone. In this video, we are going to be seeing how we can find the rank of a matrix, and there are two different methods that we can generally use to find the rank of a matrix. But specifically, we are going to be seeing how we can find the rank of a matrix using the determinants, like to find the determinant of the matrix, and we proceed. Now, the rank of a matrix regarding the determinant is simply the number of rows or columns of the largest square matrix with non-zero determinant. So simply, when we are given our matrix, we identify if the matrix is a square matrix. If it is a square matrix, then we find the determinant of this matrix, and then if the determinant of that matrix is not equal to 0, then the rank of our matrix is simply the number of rows or the number of columns of that square matrix. In that, for a square matrix, the number of rows and the number of columns are the same. So the rank of the matrix is either the number of rows or the number of columns, or just the number of rows or just the number of columns, because they are the same. Now we are going to see a case where we are given a matrix but the matrix is not a square matrix, or we are also going to see a case where the determinant of our matrix is 0. What are we going to do? So in this first example, we have been asked to find the rank of the matrix A, and the matrix A has been given. So our matrix A has been given as that, so the determinant of the matrix A is simply, you know how to find the determinant of a 2 by 2 matrix. So we have seen that the determinant of this matrix is 0, but according to our definition, we are looking for the largest square matrix whose determinant is not 0. Then the rank of that matrix will give you the number of rows or the number of columns of the largest square matrix with non-zero determinant. Now this is our largest square matrix, but the determinant is 0, so we need to look for another square matrix, and you know that for a square matrix, the number of rows and the number of columns are the same. Now originally we have a 2 by 2 matrix, so the only next largest square matrix that we can obtain here is a 1 by 1 matrix, which is just an entry. So maybe if we take M, our new matrix, to be the entry 1, we can take the entry -2 or -3 or 6. It all depends on you. Now the determinant of this 1 by 1 matrix is just the determinant of our entry 1, which is 1, and it is different from 0. Hence the rank of the matrix is 1, because our matrix M is a 1 by 1 matrix. It has 1 row and 1 column. Hence we can conclude that the rank of the matrix A is 1, because the matrix M is the largest square matrix whose determinant is not 0. So I hope it is understood. Now for the second example, we have to find the rank of this matrix. Now this is not a square matrix because the number of rows is different from the number of columns. The rows are the horizontals and the columns are the verticals. So we see there are 2 rows here and 3 columns, and the order of a matrix is row by column. So the order of this matrix is a 2 by 3 matrix. That's the order of the matrix. So the number of rows different from the number of columns, meaning it is not a square matrix. What do? We simply now move to a sub matrix. So we identify the sub square matrix and then we perform our calculations. So with our matrix A that has been given to us, we can identify this as a square matrix. The matrix, maybe you can call it M, which is 2, 4, 1, 2. Now the determinant is simply 4 minus 4, which is 0, so we cannot conclude. We go to the next square matrix that we can determine in our rectangular matrix, because when the number of columns is different from the number of rows, we refer to it as a rectangular matrix. Now that is the next, maybe we can call it N, and if we find a determinant, we see the determinant is -18 and it is different from 0. Hence this is the largest square matrix that we have obtained from our matrix A, whose determinant is different from 0, and hence by the definition of the rank of a matrix regarding the determinant, the number of rows of our matrix N is 2 and the number of columns is 2. Hence we can conclude that the rank of our matrix A is equal to 2, because the number of rows and the number of columns, or the largest square matrix whose determinant is not 0, is a 2 by 2 matrix. 2 rows, 2 columns, hence the rank of the matrix is going to be 2. So that was that for the video. In the next video, I'm going to show you how to find the rank of a matrix, not using the determinant, but this time around using the row echelon form.